Welcome to the lecture number 64, dear students. Circle. This theorem is given on page number 75, and this is called as tangent secant angle theorem. Try to understand, my wordings are very important. I said tangent secant angle theorem. I am stressing on the word angle theorem. Reason being that later on we have to study some theorems, so that time you will surely come to know why I was stressing on the point tangent secant angle theorem. Okay, now I am going to read out the statement for you, and then I will explain the proof in detail. Let's see. For this theorem, statement is as such. It is given on page number 75. If an angle has its vertex on the circle, now you will find angle ABC is under consideration, and for angle ABC we will find vertex of the angle is lying on the circle. Vertex of the angle. For angle ABC, vertex is B. Its one side touches the circle and other intersects the circle. Now for angle ABC, there are two sides, namely side AB and side BC. So you will notice AB is a secant. AB is a secant. Why it is secant? Reason being that it is intersecting circle in 2 points, A as well as B. And BC is a tangent. Why it is tangent? Because it is intersecting the circle, or even we can say it is touching the circle in point B. Then the measure of the angle is half the measure of the intersected arc. Now we are talking about which angle? Angle ABC. And what we have to prove? That intersected arc, which is ADB in this case. You all know the final definition of intersected arc. And we have to prove that measure of angle ABC is equal to half the measure of arc ADB. That is what we have to prove. Now you will find, given these all things we have to write in detail as usual. That given should be there, as well as to prove that has to be there, and all these things. No, so from that point of view, given is angle ABC. So find angle ABC is given. AB is a secant. I explained you why AB is a secant. BC is tangent. Segment BC is tangent to the circle. M is center of a circle. Now when proving this theorem, we are going to consider 3 cases. Now in the first case, center of a circle is on the side of the angle. First case is what? Center of a circle is on the side of the angle. In the second case, we are going to consider that center of a circle is in the exterior of a circle. In the exterior of the angle. I have to make correction over there. In the exterior of the angle. That will be our second condition. And third condition will be there, that center of a circle in the interior of the angle. In all these 3 cases, we have to prove that measure of this angle, which is formed, one of the side is tangent, one of the side is secant. That measure of this angle is always half the intersected arc. Okay, let's see now. So angle is ABC, and we have to prove angle ABC is equal to half arc AD. So case 1 is center of a circle lies on A. Lies on side. Side is A. M is lying over there. So you will notice very interesting thing. What is AB? AB is passing through center M. AB is passing through center M, and BC is a tangent. So naturally you will find MB, we are going to call it as a radius, while that of BC is tangent. So by tangent radius theorem, measure of angle ABC is 90. Please try to understand this. That measure of angle ABC is equal to 90. Reason being that MB is radius and BC is tangent. So an angle MBC, or even you can say ABC, reason being that all of them are collinear points. So you will find angle ABC is 90. So I have written over here. Case 1, center of a circle lies on AB. So angle ABC is 90 tangent radius theta. Now arc ADB is intersected by angle ABC, isn't it? So arc ADB, what is arc ADB? ADB is a semicircle. Why it is semicircle? Reason being that AB is diameter. And if AB is diameter, since you all know that the diameter always divides the given circle into two equal halves, and therefore you will be getting ADB as a semicircle as well as this side AB is also semicircle. But we are not interested in knowing the value of this, but we are interested in knowing the value of this. We are concerned with this arc ADB. So you will find measure arc ADB is 180 degree. Reason is semicircle. That is what is written over here. Semicircle. So from above results, if you compare these two results, very easily you can notice one thing. When angle ABC is 90, 90 is exactly half of 180. 90 is exactly half of 180. What does it mean? It means measure of angle ABC is equal to half the measure of ADB. So reason being that half measure of ADB is equal to 90. So this is very important reason that when one side of the angle is secant and other side is tangent, in that case measure of angle is always equal to half the intersected arc, and that is equal to half measure of ADB. So this is called as tangent secant angle theorem. Hope that you all understood it very clearly. There are no complications at all. ADB is of 180, ABC is equal to 90. Reason being that it is secant and it is, or you can say it is tangent and it is radius. So this is how we will be getting ABC is equal to half arc AD. Now let's see the second condition is that center of the circle in the exterior of the angle. So I am going to explain you that now. Second case I am going to write here. This theorem is very important for application purpose. Application in the sense we have to use while solving the sums. But this theorem very rarely asked to prove. So from that point of view, because what happens, some sums or sometimes you will find some theorems are so big and the maximum weightage of the marks is 4 only. So in that case, how to distribute those 4 marks? That is also a big challenge. So I am going to draw now circle over here. Okay. The circle if I draw. Now M is what? M is a center of a circle. Clear? Now please try to understand. Okay. You will notice here ABC is a given angle. Angle is ABC. Arc is AD. Arc is AD. So, but what happens here? You will notice M is the center of a circle which is in the exterior. Exterior means outside the angle. But basic condition is same. What is basic condition? One side of the angle is the secant, which is intersecting circle in two distinct points, while other side of the angle is tangent, and you will notice this is tangent. Now in this case we have to prove the same thing, that to prove that angle ABC is equal to half major arc ADB. You will find angle ABC is there, and this is arc ADB. This arc ADB is called as intersected arc, and our theorem is the same. What is our theorem? That if AB is a secant, BC is a tangent, in that case measure of angle is always equal to half the intersected arc. So I have to do construction in this case. Proof. Proof is join NB and ME. Join NB and ME. I have to prove the same thing, that measure of angle ABC is equal to half the measure of intersected arc. Now you will find I am going to label ABC as y. Let angle ABC is equal to y. So you will find angle ABC is equal to half measure of AD. That is what we have to prove. But now, for our convenience, we have taken this as y. So, if ABC, if we label it as y, so y is equal to half measure of AD. That is what we have to do. I am going to take this as x, this also as x. I will explain the reason for that, why they are x each. So angle ABC is equal to half measure of ADB, but I have taken angle ABC as y. So I am going to prove now angle y is equal to half measure of ADB. This is our case number 2. Even you will find we have to prove case number 3 also. Case number 3 also. So y is equal to half arc ADB, that is what actually we have to prove. Now please try to understand all the things I am going to write out right here. You will find in triangle MAB, which triangle? MAB. Please consider this triangle. In triangle MAB, in triangle MAB, MA is equal to MB. MA is equal to MB. Radius of cylinder. MA is equal to MB. Radius of cylinder. So naturally you will find if two sides of triangle MAB are congruent, two sides of triangle MAB are congruent, that namely MB and MA, then triangle MAB is an isosceles triangle. I hope it is very simple to understand. If two sides are common, naturally base angles are common. This is an isosceles triangle. Therefore, you will find angle A and angle NBA. Angle A is congruent with angle NBA. That is equal to x. Reason is also by now you must have come to know. What is the reason? That base angles of isosceles triangle. Base angles of an isosceles triangle so you will notice angle A, I am talking about this angle, is equal to angle AB and that is equal to x. Base angles of isosceles. What is our aim to prove? Angle Y is equal to half our AD. We have done construction of joining M as well as NB and we have got x each, reason being that N is equal to N, which are radii of the same circle. Therefore, we got these two angles as base angles of isosceles triangle. Okay. Now you will find, if I consider this whole angle, measure of this angle NBC, angle NBC is equal to x plus y and that is equal to 90. Try to understand this. Angle NBC is equal to, this is what? Radius, this is what? Tangent. So we find angle NBC is equal to x plus y and that is equal to 90. Fine. Tangent radius set. Tangent radius set. BC is tangent and NB is radius, and that is why you will find angle formed by this radius and tangent. This whole angle is of x plus y. NB is equal to x plus y, that is equal to 90. So x plus y is equal to 90. X plus y is equal to 90. Therefore, y is equal to 90 minus x. Y is equal to 90 minus x. You will surely think, why 90 minus x? Very simple calculation. I transfer x from right hand side and I got it as 90 minus x. Y is equal to 90 minus x. Y is equal to half major arc ADB. That is what we have to prove. And y is equal to ABC. That is very important. That y is equal to ABC. So y is equal to 90 minus x. I am going to call it as result 1. I am going to call it as result. Now please focus. Please focus only on triangle NAB. Don't think this y at all. Okay. So in triangle AMAB, I am talking about what? MBA or NAB. NAB you can say. In triangle NBA. In triangle ABB. MBA is this triangle. Very easy to see over here. Now in MBA, you will find x plus x is 2x and sum of the angles of triangle is 180. Sum of the angles of triangle is 180. Now, angle B and A, please try to understand. Angle B and A is equal to 180 minus 2x. This is x, this is x. Then B and A. Sum of the angles of triangle is 180. And you will surely find if this is x, this is x. Naturally, sum of these two is 2x. So, remaining angle, that is B and A, is equal to 180 minus 2x. Fine. Now, if B and A is 180 minus 2x, but N is a center. But N is a center of the circle. So, angle B and A, this angle is called as central angle. We have studied it. So angle BMA is called as central angle. And you all know also that measure of central angle is equal to measure of intersected arc. Measure of central angle is equal to measure of intersected arc. Now I am going to insert arc ADB in this result. Why? Because finally we are concerned with angle ABC and arc ADB, nothing else. So I am going to write, instead of BMA, I will write arc ADB. So measure arc ADB. Measure arc ADB is equal to 180 minus 2x. Central angle BMA. Central angle BMA. Central angle BMA is equal to arc ADB. So BMA is equal to arc ADB. That is what I have written. I replace angle BMA by arc ADB. These are ADB. Fine, because central angle is always equal to intersected angle. Now next step you will find. Next step you will find. Measure arc ADB is equal to if I take 2 as a common from these two terms, we can take common. Because 2 divides 180 as well as from 2x also we can take 2 as a common. Very simple. So if we take 2 as a common from both these terms, then 2 into bracket. Taking common means indirectly we are dividing those terms by that common. So if I take 2 as a common from these two terms, then I will be getting 90 minus x. 90 minus x. Very simple. I have taken 2 as a common, so 180 divided by 2 is 90 minus x. Fine. So this is nothing but 2 upon 1. This is nothing but 2 upon 1. If 2 upon 1 is transferred to the left hand side, that becomes 1 upon 2. That becomes 1 upon 2. If I transfer 2 upon 1 to the left hand side, it becomes 1 upon 2. That is equal to 90 minus x. Label this as result. Now you will notice two things. Result 1 is 90 minus x, isn't it? And result 2, half measure arc ADB is 90 minus x. Is it here in this case you will find y is equal to 90 minus x. So right hand side of result 1, 90 minus x, as well as right hand side of result 2 is also 90 minus x. So surely we can conclude that left hand side of result 1 as well as left hand side of result 2 are same, because their right hand sides are same, 90 minus x each. Here also we will find 90 minus x. Here also we will find 90 minus x. So we can say from result 1 and 2, from 1 and 2, or even you can say comparing 1 and 2, 1 and the same. So y is equal to half measure of ADB. Please try to understand. Right hand side of 1 is 90 minus x. Right hand side of 2 is also 90 minus x. So comparing their left hand side, y is equal to half measure of ADB. But what is y? Y is nothing but angle ABC. From figure only you will understand it very easily. angle ABC is y only. Angle ABC is y. So I am going to replace y not ABC. Okay, let's have a review of this very quickly. Our aim is to prove ABC is equal to y. I am going to explain all the things once again. MA is equal to MB. Please have a look. MA is equal to MB. These are radii of the same circle. MA is equal to MB, radii of the same circle. Triangle MAB is an isosceles triangle. Triangle MAB is an isosceles triangle because MA is equal to MB. Now, angle A is equal to angle MBA is equal to x. Base angles of isosceles triangle. Please look here. MAB is A and MBA is this angle. So, since MA is equal to MB, base angles are congruent. Base angles of isosceles triangle. Now, angle MBC is equal to x plus y. Please look here. MBC. So MBC is nothing but MBA, which is x, as well as ABC we are taken it as y. So MBC is equal to x plus y. But x plus y is 90. Why it is 90? Because this is radius and this is tangent. We have studied tangent radius there. According to that, x plus y is 90. So y is equal to, if I transfer x from right hand side, y is equal to 90 minus x. I label it as 1. Next to that, in triangle NPA, please look here. In triangle NPA, sum of the angles of triangle is 180. So if this is x, naturally this BMA is equal to BMA is equal to 180 minus 2x. But BMA is a central angle. This is a central angle. Why this is central angle? This is being very simple. Vertex of the angle is at the center. And central angle has intersected R BDA. So measure of central angle is always equal to the intersected R. Therefore, we will be getting here angle BMA is equal to 180 minus 2x. If this is 180 minus 2x, our ADB is also 180 minus 2x. Next to that, I continue this over here. I simplified it right hand side and I have taken here 2 as a common. So if I take 2 as a common, I will get inside the bracket 90 minus x, because taking common means indirectly divided. So 2 upon 1. So measure 2 upon 1. If I transfer to the left hand side, I will be getting 1 upon 2. We have to take the reciprocal of this. So half measure of ADB is equal to 90 minus x. Now right hand side of 1 and right hand side of 2 are equal, 90 minus x each. So from 1 and 2, or even you can say comparing 1 and 2, you will be getting y is equal to half measure of ADB. But what is y? Y is nothing but angle ABC. So this is how you will be getting angle ABC is equal to angle ABC is equal to half measure of ADB. This is our case number 2. In case number 1, we have studied. Okay, please have a look at this. I am going away for a short time so that you can see it very clearly. You can pause the video and you can write this. Okay, now I am going to consider case number 3. Case 3 is center of a circle. Sorry, yes, right. Center of a circle is in the interior of the angle. In this case, we have studied center is in the exterior. Case 3. Center of a circle. Center of a circle. Center of a circle in the interior of the angle. Center of a circle in the interior of the angle. Here also you have to understand this very carefully. I am going to draw a figure for this now. Angle is given as angle ABC. Angle is given as angle ABC. In this case, M is the center. M is the center. But center is where? In the interior of angle ABC. Center of a circle in the interior of the given angle. M is the center, angle is same ABC, BC is tangent, while AB is the secant. We have to consider all three cases, and we have considered also. In the first case, center was on the side of the angle. In the second case, center was in the exterior of the angle. In the third case, angle is ABC and center is in the interior of the angle. In this case also, we have to prove the same, that to prove that angle ABC is equal to half measure of AD. We have to prove same, result is same in all three cases. Whether it is on the side of the angle or whether it is in the exterior or whether it is in the interior. Condition is one side should be tangent and other should be secant. Okay. Now we will find this ABE. Can you see angle ABE? ABE, for angle ABE, B is tangent and AB is secant. Center is in the exterior. So you will find angle ABE is equal to, please try to understand. Angle ABE is equal to half measure of AFB. Half measure of AFB. B is tangent and AB is secant. Center is in the exterior of the angle. From result 2, you can see from case 2, better to see. from his. So AB is equal to half measure of AB. Now please try to understand. Measure angle ABE. Measure angle ABE plus measure angle ABC. Measure angle ABC is equal to, please try to understand, ABC plus ABE, they are angles in the linear pair. Is it very simple to understand? AB as well as ABC, they are angles in the linear pair, that is equal to 1. Angles in the linear pair. Clear? Now please try to understand. Angle ABC is equal to, angle ABC is equal to, our final result is in terms of ABC. That is why we are interested in ABC. So angle ABC is equal to 180 minus angle ABE, measure angle ABE. I have simply transferred this AB on right hand side. So I got it as 180 minus ABE. Okay. So angle ABC is equal to 180 minus angle ABE. Now next step is, I am going to simplify this now. So angle ABC is equal to, angle ABC is 180 minus 180 minus measure angle ABE. Okay. Measure angle ABE. But what is value of angle ABE? Angle ABE is equal to half measure of AFB. Try to understand this. Because this is in case number 2. If BE we consider as a tangent and AB we consider as a secant, then we can surely use the same, whatever result we got in the second case, that angle ABE is equal to half measure of AFB. So I am going to substitute half measure R, half measure R AFB. Okay, now if I label it as 1, if I label it as 1, now try to understand. ABE is equal to half measure of AFB. Very simple. Second case, center is in the exterior of line. So ABC is equal to 180 minus half measure of AFB. That is result 1. Then secondly you will find measure of AFB, measure R AFB plus measure of ADB is equal to 360. Sum of the arcs of a circle. Sum of the arcs of the circle. You all know, if we add all the arcs of a circle, their sum is always 360. The same theorem I used over here. We will find this is AFB is from here to here, ADB is from here to here. So if we add this total AFB as well as ADB, you will be getting 360. So that is what is written on here. Now my aim is to substitute for half arc AFB. So what I will do, this side I write it as measure arc AFB, measure arc AFB is equal to 360. Right hand side is what? 360. I am going to transfer this AD minus measure arc AD. 360 minus measure arc ADB, nothing. Only I have transferred this ADB on right hand side. Now I have to get this value, half measure arc AFB. Okay. So you will find here, if I take 2 as a common, once again I tell you, taking common means what? Taking common means we are dividing the terms from where we have taken that as a common. So in this case you will find, if I take 2 as a common from 360 as well as measure arc AD. Now if I take 2 as a common, I will get 180. What I will get? 180 minus. If I take 2 as a common, I have to divide this measure arc AD. Taking common means dividing both the terms by 2. So here I count 2. Okay, 2. 360 upon 2 is 180. Here half measure arc AD. Try to understand this concept very clearly. When we take common from any two terms, that time we are dividing both the terms by that common. So if I divide 360 by 2, I will be getting 180. And here, if I cannot divide it, I am writing the form of division. So half measure arc AD. Now here I get half because 2 upon 1. If I transfer it to the left hand side, half measure arc AFB, half measure arc AFB. 2 upon 1 is this side, 1 upon 2. That is equal to, right? That is equal to 180 as it is. 180 as it is minus half measure arc AD. My aim is to find out value of half measure arc AFB. So half measure arc AFB is equal to 180 minus 1 upon 2 arc AD. Half measure arc AFB is equal to 180 minus half arc AD. Now substituting substituting 2 in 1. Substituting 2 in 1. Substituting. In 1. Equation 1. What is equation 1? Angle ABC. Okay, I'll write here. Angle ABC. That is equal to 180. Okay, this 180 as it is. Minus and minus. Half measure arc AFB. Minus. Half measure arc AFB. But what is value of half measure arc AFB? 180 minus 180 minus half measure arc AD. Half measure arc AD. Very important. That is what I say, substituting 2 in 1. Meaning of this is same, that you have to substitute the value of half measure arc AFB is equal to 180 minus half measure arc AD. The same thing I am written over. Now if I open the bracket, is 180 Minus into plus is minus. Opening the bracket. Minus into plus is minus. But minus into minus is plus. So half measure up AD. Plus 180 minus 180 cancel. So you will be getting angle ABC is equal to half measure up AD. Half measure up AD. So this is our third case. Please try to understand in third case what we have done. First of all, angle ABE is equal to half measure of AFB. Then angle ABE plus ABC is equal to 180. So angle ABC is equal to, this is important story, 180 minus half measure of AFB. Half measure of AFB means angle ABE. The value of angle ABE is half measure of AFB. That is equation 1. I will label it as 1. Later on, measure of AFB plus measure of ADB is 360. AFB plus ADB is equal to 360. Clear? Sum of the arcs of a circle. Reason is also given. So measure of AFB is equal to 360 minus measure of ADB. I have not done anything else. Simply I transfer this ADB on left hand side. So AFB is equal to, this is very crucial step to understand. So I have taken 2 common over here. If I take 2 common, taking common means what? Taking common means the terms from which we have taken that as a common, we have to divide those terms by that common. So if I divide 360 by 2, I will be getting 1. If I divide this R, so here I have to write in a symbolic form. 1 upon 2 measure of ADB, nothing else. So if I transfer 2 upon 1 to the left hand side, it becomes 1 upon 2 measure of AFB is equal to 180 minus half measure of ADB. This is our result. So you will find here, if I substitute these 2 in 1, 2 in 1, means what I am going to do now, value of half our AFB I am going to write here. So ABC as it is, we will find ABC as it is, 180 also as it is, okay, 180 is also as it is, minus sign, in the bracket, value of half AFB is 180 minus half measure of AD. 180 minus half measure of AD. So 180 as it is, minus 180, minus is plus, 180 gets cancelled and ABC is equal to half measure of AD. This is how this theorem is over here. This is only a theorem. You will be surprised to know. This is only a theorem. To complete this, entire 45 minutes are wasted. I will not say wasted, but we have to put in total 45 minutes. Naturally, this question will come in your mind that in examination, if the same theorem comes, how you are going to spend 45 minutes to write all these 3 cases? Of course, very rarely this theorem will be asked in the examination. Very less possibilities are there. That is one thing. And second thing is that even in case if they ask, they will ask only one case, that whether the center is lying on the side of the angle, center is in the exterior of the angle, and center is in the interior of the given angle. But only applications are very, very important. So revise it. Actually, in many teachers drop this theorem, proof of this theorem, they drop. They simply give the applications. But you should not think in that way also. Sir is able to prove this or not, whether it is possible or not. It is given in some different manner in the textbook. this third case, I have proved it by simple case. But to understand all these three cases are important, as I stated just now, that one of these three cases they may ask in the examination, but very rare chances are there. Applications are very important. So once again, I am very much thankful to all of you dear students for listening this lecture very carefully, as well as please see this video and try to understand the concepts. God bless you all. Thank you very much.